Are we alone in the universe? Or have we simply not been looking the right way? If there are billions of planets out there, how is it possible that none of them have answered us yet? And what if the silence we perceive is not emptiness, but a warning? These are questions that have lingered in the minds of scientists, writers, and dreamers for decades. The Fermi paradox sums it up well. Considering the vastness of the universe and the high probability of extraterrestrial life, why haven't we had contact with any civilization? Welcome to Astroracle, where we explore the vast universe together. The first thing we need to ask ourselves is whether it really makes sense to assume that the universe is full of life. Until just a few decades ago, we didn't even know if there were planets beyond our solar system. Today, that story is very different. Astronomers have confirmed the existence of more than 9,000 exoplanets, a figure updated in mid-2025, and the number continues to grow. It's estimated that every star has at least one planet orbiting it. In our own galaxy, the Milky Way, there are more than 100 billion stars, and the observable universe could contain more than 2 trillion galaxies. At first glance, the odds of other Earth-like worlds existing seem extremely high, but the picture changes once we narrow the filter. Most of those planets are gas giants, scorched by their proximity to their star or frozen in distant orbits. Only about 5% of the discovered exoplanets could lie in the so-called habitable zone, the region where liquid water could exist on the surface. And within that small percentage, even fewer are rocky, with stable atmospheres and conditions similar to Earth's. In other words, planets are abundant, yes, but the actual candidates for hosting complex life remain very limited. Rarer still is the chance that such life would evolve into something resembling us, being capable of developing science, technology, and interstellar communication. In 1961, astronomer Frank Drake tried to give a mathematical shape to this dilemma. His famous equation seeks to estimate how many civilizations in our galaxy might be able to communicate with us. The formula includes factors such as the rate of star formation, the number of habitable planets, the probability of life emerging, the evolution into intelligent forms, the development of communication technologies, and the duration of that technological phase. The problem is that many of those numbers remain pure conjecture. What is the real probability that a planet with life will develop intelligence? How long can a civilization sustain its technological development before collapsing or disappearing? Some modern calculations are pessimistic. Even if there are millions of planets with life, the percentage that would reach the technological stage might be as low as 0.01%. In that case, we could be more of a cosmic rarity than the norm. Let's suppose advanced civilizations really do exist. The next problem is obvious: distance. Space is immense, and the speed of light, the fastest thing we know, is still not enough to bridge it within human timescales. A signal sent from a planet 1,000 light years away would take 1,000 years to reach us, and another 1,000 for our reply to get back to them. To make matters worse, these civilizations might be using communication methods completely different from ours. While we're still searching for radio waves, they could be using laser pulses, neutrinos, or even quantum transmission forms we don't yet understand. In that scenario, SETI's radio antennas would be like trying to tune into Netflix with an AM radio, utterly useless. Here emerges one of the most unsettling hypotheses: the Great Filter. The idea is that all civilizations face a critical barrier that most never manage to overcome. That filter might be at the very beginning. Perhaps life itself is extremely rare in the transition to complex organisms, or further along when a technological society confronts its own risks of destruction. Then comes the big question: have we already passed it, which would make us truly exceptional? Or is the worst still ahead of us? Some believe climate change could be that filter. Others think it might be nuclear weapons, uncontrolled artificial intelligence, or even a global ecological collapse. If this filter is inevitable, then perhaps all technological civilizations are doomed to vanish before leaving any detectable trace in the cosmos. Another, far more chilling hypothesis is the dark forest theory, popularized by Liu Xing's trilogy. Imagine the universe as a forest in the dead of night. Every civilization is a hunter walking among the trees, armed and on the edge. No one knows how many others are hiding in the darkness, nor what their intentions might be. In that scenario, the safest strategy is absolute silence. If you make a sound, you reveal your position, and someone more powerful could destroy you. According to this view, all intelligent civilizations choose to remain silent, conceal their existence, and simply watch from afar. What we interpret as a silent universe might, in fact, be a universe filled with hidden eyes that prefer to go unnoticed. Far from giving up, science continues to push the boundaries. In recent years, several initiatives have brought fascinating results. The Chinese Fast Radio Telescope, the largest in the world, has expanded the search for signals and is studying mysterious phenomena such as fast radio bursts, also known as FRBs. Although they most likely have natural causes, the possibility that they could be used as artificial signals hasn't been ruled out. The James Webb Space Telescope is analyzing the atmospheres of exoplanets in search of biosignatures. Gases such as oxygen, methane, or even industrial compounds that could indicate biological or technological activity. New optical SETI programs are searching for ultra-fast laser flashes, based on the idea that an advanced civilization might communicate through pulses of light far more effective than radio waves. And soon, the Vera C. Rubin Observatory will begin mapping millions of galaxies, opening up the possibility of detecting anomalies that could point to large-scale technological activity, such as the hypothetical harnessing of stellar energy by Type II civilizations on a Kardashev scale. Here, another rarely discussed problem arises: protocols of contact. What happens if tomorrow we receive an unmistakable signal from another civilization? Who responds? Governments? Scientists? The UN? What message do we send? Today, there are drafts of protocols, but none with global consensus. And worse, no one can guarantee that publicly announcing a discovery of such magnitude wouldn't trigger panic, conspiracy theories, or even hasty attempts to reply, exposing us to unknown risks. So, what does all this mean? Perhaps life is much rarer than we think. Perhaps it's out there, but too distant or too silent. Perhaps all civilizations die young, unable to survive their own progress. Or maybe the universe isn't empty at all, but full of observers watching us like a newborn who hasn't yet learned to walk. If you're enjoying the video, give it a like, and subscribe to the channel for more content like this. And don't forget to hit the notification bell so YouTube can let you know when we upload a new video. The universe is overwhelmingly vast, and logic tells us that we should not be alone. Yet, to this day, the only thing we receive from the stars is silence. That silence can be hope, a warning, or a mystery. But the truth is that, until we have clear evidence, we remain the only known civilization. And that solitude, at the same time, makes us both fragile and unique.